Hello. We're going to delve into a couple of different topics today. They're a little bit far apart from each other, but they're both very relevant in terms of being able to properly set up classes and use them in a way that's more like what you would actually see in a real software environment as opposed to the sort of artificial landscape that we're dealing with in this course. So the first we're going to delve with is exception handling, and then after that we'll start looking at the modular programming side of things. So starting with exception handling, we're going to make a food item class with a private attribute temperature. If the temperature is set above a certain threshold, using the setter function, throw a runtime error exception, and we'll handle this in our main function. So let's go straight into that. 61. All right. We're in week 5. Let's make a file. Exercise 1. Okay, we need to make a food item class. Let's do that. Class food item. Private attribute called temperature, which I guess will be an integer. Makes sense to me. Temperature. When we create a food item, we can either just do nothing, or we can set the temperature to be T. And we also want a getter and setter for this temperature, so those will have to be public, like our constructor, so that people can actually use these functions. So we'll have void set temperature, which is going to take a value and set temperature equal to T, and a int get temperature, which will return the temperature. Wrote this pretty quickly, but this is kind of just the basics of setting up a class that's going to have private variables, some public variables to access it and set it. But we're obviously not done yet, and in fact, we're not even correct in what we're trying to do here, because if the temperature is set above a certain threshold, throw a runtime error exception and handle this in my main function. So we'll start by throwing the exception. We'll figure out how to handle it after. So here's what we have to do. This function is going to be a little longer. If the temperature we want to set it to is bigger than or equal to, let's say 100, that seems like a pretty spicy piece of food. We will throw a std : runtime error. I always forget the format of these, but I do believe that this is supposed to have a parameter which is the message that shows up. Which is going to be food is %d degrees : too hot. I believe that's correct. I might need to include IOStream. And I'll make a main function and compile this to make sure that I have the right syntax. It's been a while since I've written any exceptions. Usually use a lot of automated things to help me with that. G++ exercise 1. So this is our food item. Yeah, that seems okay. Now, so the idea here is that when I set the temperature, if the temperature is too hot, I want to throw an error. I want to basically toss out what I'm working on right now, sort of exiting this function, and say, you know what, this isn't going to work. Why? Well, the food is too hot. If this isn't going to happen, then I just have the temperature. So I'm going to get a food item, and it will start with a temperature of, we'll call it Fi, is food item. We'll set it with a temperature of 20 to start, and see what happens if I do fi.set temperature to be 101. So I run food item. Terminate called after throwing an instance of runtime error. So this means that it ran into the line where I said, oh, this food is too hot. And what happened is it says the food is too hot. I seem to have messed up my I want to, so this is a string. I think I can use a format specifier. Let me see. Comma T, can I do that? No, I can't do that. Okay. Well, I'm used to using printf, and in printf I can do comma T. I want to figure out how to get the D in here. I think maybe I can concatenate some strings. Let's see if that works. And this would be toString T. How's that go? Still unhappy? Oh yes, the standard toString. Lets me do that. Now let's see. There we go, look at that. Food is 101 degrees, too hot. So, let's sort of break down what's happening in this line. Throw is a keyword. This means to basically terminate, not necessarily the entire program, but at least exit what you're doing right now because something went wrong. What went wrong? I've labeled it as a runtime error. So this means while the program was running, something went wrong. What is the thing that went wrong? Well, I can construct any string that's going to explain the problem here. And the problem here is I said that it's supposed to see what happens if the temperature is set above a certain threshold. And I said 100 because we got to pick a number. But if the temperature is above 100, which it is in this case, then I say too hot. Otherwise, I'll set the temperature. So down here below, just to see what this might look when I do output, the temperature of the food item is %D, and this is where I put in fi.get temperature. So if I don't set it to be 101, I just set it to be 20, then all that happens is, what did I mess up? Oh, I forgot the parentheses right here. Parentheses. Let's try that again. Okay, compile's okay. And now it says the temperature of the food item is 20. So that's normal. If I set it to be too hot, though, you'll see I don't print out this message because as soon as I hit the line that says throw this error, the code stops. It's like, okay, I'm not going any further. Now, we can fix this, though. And the way to fix this is to sort of expect that an exception could happen and predict it. So we use a combination of code blocks here. The first one is called try, and in here we encapsulate everywhere where we think an error might happen, or specifically an exception might be raised. And here I imagine that it's going to be in this block. And when you try to see if an exception happens, at some point you can imagine an exception is literally being thrown at your face. And what you do if something's being thrown at your face, you try to catch it. So catch is the other keyword here. And catch requires an explanation of what I am catching. And in this case, there's a few ways you can different do it. If you're sort of lazy like I am, the default is you can actually just put 3 dots, and this will catch anything that happens. And then you can decide what to do with it. So in this case, what I might do is do something like printf that is too hot of a temperature to set. You know. So now let's see what happens when I run this. Clear, compile, run. So that is too hot of a temperature to set. And you notice it keeps going. The temperature of the food item is 20. So it refused to set it to 101. And rather than just crash the whole program and print out this message, it just continued onward with its original temperature of 20. Now, let's make this a little more accurate. That is a little unspecific. So we'll do percent. We'll say let's use a variable here. So int start temp equals 20. So this can be start temp. Int new temp equals 101. So this can be new temp. Now I can do %d is too hot of temperature to set, and that is new temp. Just so that this is a little more consistent, I don't want to be writing in numbers inside of my print messages. I should be using variables to track everything for the sake of being able to only modify one number if I want to. So now I can modify my starting temperature, and it only needs to be put in one spot as opposed to being in several different places, and the same thing for the new temperature. So I think I've completed all of what it asked me to do. I have a food item class that has a private attribute temperature. If the temperature is set above a certain threshold using the setter function, I throw a standard runtime error, which is what I do. and I handle this in my main function. This is the most basic way to handle it, and maybe in a future exercise, in one of the upcoming ones, I guess, I'll show more useful ways to actually deal with these kinds of errors, but this is kind of the basics of how to handle an exception. So you throw one when something is wrong. You can specify whatever type of error you want it to be. Runtime is a pretty common one. The string in here is the message that will pop up if it is not caught, but if it is caught, you can decide what you're going to do about that. And here I left things kind of blank, which basically just says catch any exception that happens and do something with it. But we may want to actually handle different exceptions different ways, and we'll get ahead to do that within the next few exercises, I'm sure. We'll see. Okay, so next exercise. Create a class called overcooked exception. If a food item object's temperature is too high, throw and catch an overcooked exception. Make sure your overcooked exception class has a what method. So we saw what popped up when we were not able to catch our exception from before. So if and we saw, I think I cleared it, but just to take a look at what it looks like. So I comment this out and I compile and run. I forgot to, I gotta set the temperature. Of course. Compile and run. So you can see there's what here, and what is what with parentheses is a method that belongs to most exception classes, which is specifically there to explain what happened. Why did something go wrong? What is the explanation that's here? Now, in my code, when I have an exception, it says to throw a runtime error, but this is very generic. Like a runtime error could be anything. So instead of throwing a runtime error, what I'm going to do is I'm going to throw a brand new type of exception, which I'm going to make. So in my new exercise, it says here to create a class called overcooked exception. If food item's temperature is too high, throw and catch it. Make sure it has a what method. So here we go. Class overcooked exception. And it's going to have a what method, and I believe the what method here is just going to return a string. So public string what? And probably I should have a constructor that's going to store this. So here's what we'll do. Make a private message. And when you make an overcooked exception, you can either do nothing, or you can pass it a string message, which gets put into the message. And what is going to return the message? This keeps it really simple. Yeah, okay. So basically all this overcooked exception class does is it stores a string, and the what method of overcooked exception will return that string. And you can use a constructor to put that string in, and that's about it. Kind of a basic class, but the important thing here is that it's a specific type of exception that I think might happen. Now, down here, instead of throwing a runtime error, what I can actually do is I can throw a overcooked exception. And then finally, so this should do actually the same thing. Like there shouldn't be any difference, I think, in what happens when I run this code. Just to confirm that, I'll run it again. And this is going to be our overcooked exception. Oh, it's unhappy about something here. What is the problem? Oh, okay, I'm gonna get a little lazy here and use namespace std in. I guess I can put the symbols in the right spots. This one goes here, this one goes here, and that should be good enough. Clear it, try it again. Okay, there we go. Okay, now when I run overcooked, I believe it does the same thing. 101 is too hot of a temperature to set. I really should put a new line character in here so it looks a little less ugly. Let's make that a little nicer looking. There we go. But nothing really different has happened. However, what I might want to do is catch a specific kind of error. So instead of just catching anything, and here I might specifically say something like, just generic error or something like that, printf error. Who knows what that could be. Here I can say I want to specifically look for a overcooked exception. I will call it E for exception. And if that happens, what I will output, and I'll use cout for this. You actually can, if you really want, we'll use cout, but I want to see if actually there's another way that you can output stuff, and we'll see if that works after. But for now, we'll output e.what. What did I mess up? Oh, so I messed up. I forgot this. And I think I need the arrow here, but I'm not sure if that's true. Nope, okay. It should be e.what. What did I mess up here? It might be that I don't need to have these things. Let's see if that helps. Clear, compile. There we go. I think it might have been unhappy about the ampersand. And it's probably unhappy about the constant then. Yeah, so it's not particularly happy about declaring this as a constant, so we're not going to do that. Probably shouldn't be a constant anyway. We're looking for a very specific overcooked exception. So now when I run this, this is the least exciting part. Look, it does the same thing. Which is, it says food is too hot, but it doesn't say error. If I wanted to say error, I can comment out this catch block, and now it will say error instead. So when you say try, you can then follow it up with as many catches as you want, and every catch can declare exactly what kind of exception you're looking for. If it's the case that I'm looking for specifically for an overcooked exception, I can maybe output that. But if I catch something else, maybe I want to say error or whatever else is an appropriate error message. But this way I can distinguish between the different error messages that are there. I think you can also use CRR for the error to see if this outputs things a little differently. I don't think it will appear any different because we're just in Unix right now, but it's possible that in different environments you might see something different if you use cout versus CERR. Okay, exercise 2 is done. Let's do exercise 3. Okay. Extend the food item class to have a salt level attribute. Throw us toSalty exception if the salt level is too high, and handle multiple exceptions in the main program. Well, we kind of already are handling multiple exceptions, but we'll add one more for the toSalty exception. So, duplicate. Okay. All right, so same as over here, we're going to have int t, int s, and this will be our salt level. I think I said to write it like this, although I should probably make this properly formatted. So this should be salt level if we're going to use good practice with our names. Salt level, there we go. And salt level. Temperature is T. Salt level is S, and when we make our food item, it will have a int start salt equals 1, int new salt equals 10, starting temperature, starting salt. So now our food items have a temperature and a salt level, and we're going to try to set the temperature and set the salt level and see what happens when things go right or wrong. So I'm definitely going to need all this, except instead of setting the salt temperature, setting the temperature is going to set the salt level. So this should be set salt S. And we'll say if S is higher than or equal to 10 to throw a toSalty exception. And here we'll say it's just food has string s salt to salty, otherwise salt equals salt level equals s, and then get salt will return the salt level. Kind of a tedious or relaxing, I guess, depending on the kind of person you are, procedure. But all we've done here is sort of copied the set and getters for temperature and use them for salt as well. Now, we got an overcooked exception. Unsurprisingly, we're going to have a too salty exception. Just to distinguish the two of these, maybe we'll make our message a little different. We'll say, so salty plus message. Just for a little extra salt there, that's all. Okay, so right now we are setting the temperature. Let's set the salt as well. Set salt to be the new salt. We catch an overcooked exception, otherwise we catch an error. The temperature of the food item is this, and we'll do the salt level of the food item is fi.get salt. Okay, so right now, this should just show us that it is too cooked. So let's see what happens. Oops, sorry, we're on exercise 3 now. And this is salty. Okay, what did I mess up? Let's find out. So the thing I messed up is I was unhappy about the parentheses up here. What did I do? What did I do? I have a too salty exception. It should be too salty exception, but it was overcooked exception. Okay, try that again. Okay, we're good. Salty. So food is 101 degrees, too hot. So it doesn't change anything. Now let's make it so it isn't too hot. We'll say make it, I don't know, 25 degrees. Not just its error. It managed to change it to 25 degrees, but it did not manage to change the salt level because as soon as it tries to set the salt it tried to set is too high. It tried to set it to 10, which is beyond the threshold that I arbitrarily set, and it says that it's too salty. However, it's supposed to say, food has blank salt too salty, but I haven't caught the too salty exception yet. It gets caught over here, but I don't really use that. All this is going to do is print generic error. I can't actually access my specific too salty message. So to do so, I need to catch a different kind of exception, which is a too salty exception. And now it will print a different error message. So salty. Food has 10 salt, too salty. And there we go. Once again, I was unable to change the salt level because I was too salty. Okay, so now we are catching either an overcooked exception or a too salty exception or just whatever else. And we print out what happens after we try to set the temperature and salt to whatever levels we attempt. All right, one more exercise for exceptions. We'll see how that goes. All right. In the food item constructor that creates a new food item object using user inputs for temperature and salt, use try catch blocks to handle exceptions at different levels of the preparation process. So right now when we create a new food item, we just pass things directly to the, this should be in a food item constructor. So right now right now we have to make all food items by passing in data. But what if I want to actually enter numbers into it? So what I can do is I can modify the empty constructor. And we'll actually write it down below because it's going to be a little lengthier. So this is our food item constructor. There's no parameters because we are going to collect them from the user. So here's our instructions. Okay, so I need to get a temperature and a salt level. So I also need to get user input. So int input scout. Please enter a starting temperature. And then they will enter something into input. And now I'm going to check to see if input is greater or equal to 100. So now I guess it kind of depends on what I want to do with these try-catch blocks. So one option is that I can, maybe what we'll do is we'll let them enter a starting temperature and a starting salt level, but if they enter in something stupid that doesn't make any sense or is far too hot or is far too salty, we will say, that's too much, and just set it to a static level. You can obviously do other things than this, but just to sort of demonstrate how we can use this, here's what we'll do. So we are going to see if the code here is going to result in a overcooked exception. And here we'll throw a overcooked exception, and the message is going to be initial temp too high. Seems fine with me. Otherwise, we will set the temperature to be the input. And we will catch this overcooked exception. We'll call it E. And we'll output the message. And if the initial temp is too high, we will set the temperature to be equal to 50. Temp to 50. I guess I don't need two end lines. Gotta remember to use my std::: as well. Okay, so this seems good for me. And we'll do it one more time, except this time it'll be specifically for the salt level. So salt level, if the salt level is over 10, throw a too salty exception. Initial salt is too high. The salt level is the input. Catch the too salty exception. So initial salt level to, let's say, 5. The nice thing was that you saw that it was actually really quick to do the second one of these, because all I had to do was just modify the things that were previously to do with being overcooked, and now to do with being too salty. I do realize that I have made a slight error, which is I forgot to duplicate this. So that's going to be number 4. And I actually need to revert exercise 3 back to how it was before I put in the new content. There we go. As we were, okay. Yeah, so our new food item constructor, when given nothing, will prompt the user to try to enter proper values. And if they don't, it will just set them for you. So let's try this out. So instead of using our starting temps, we are actually going to just make a food item fi equals food item. See what happens. Clear. Compile exercise 4, which is going to be our input with 2 T's for fun. Starting temperature, let's say I set 76, and my starting salt level is 2000. So the initial salt level is too high. It seems like a whole bunch of things have happened. Oh, right, because I'm I'm trying to reset them here, which I don't want to do. So let's get rid of these parts of the code as well. There we go. Let's do this again. Starting temperature 76, starting salt level 100. So so salty, the initial salt level is too high, so we're setting the initial salt level to 5. So temperature is still 76, but the salt level is 5 because I was being a little ridiculous. All right, there we go. So it is important to sort of see how the exceptions get bounced around the program. You can think of them literally as being thrown from one place to the other. This is particularly useful if, for instance, you want all exceptions to have things in common. For instance, if you always want any too salty exception to be accompanied by the phrase so salty, you can just put it inside of the class here, inside its what method, and then every time that you have too salty exceptions pop up, whether it's here, whether it's inside of your main function, you can always have that behavior shared between your different kinds of exceptions. You just remember when you want to catch the appropriate ones, or if you just want to handle them all the same, you can use the ... to do so. All right, that wraps up for exceptions. So now we're going to start looking into modular programming. Okay, let's look at exercise 5. Create a dish class that contains a vector of food items. Separate its declaration into a header file and its implementation into a CPP file. Include the header file in your main program. Okay, so in order for this to work, we're actually going to need to split up a few things. And I'm going to put all of this into exercise 5. So, first we'll make a file that's going to contain our food items. And we'll call this fooditem.cpp. We're also going to make a file for our dish class. We have the code for that. And here we'll write the little explanation. And we're also going to make a header file for it. Dish.h. Last but not least, we'll have main.cpp, which will just have our main function in it. So from everything from exercise 4, we're going to split these up into all of the different files that are here. So I'm going to grab everything related to food items, and I'll put that in here. Everything related to main will go into main. We also need to do some inclusions, but we'll work those out later. Now, my dish.cpp is going to need to have a few things in it. It's going to need to include iostream. It should also include fooditem.cpp so that I can actually know what a food is. And we're going to declare our class dish. I think we'll also need a vector. And we'll need to do private C : vector of food items called foods. And publicly, we'll have a dish constructor, which doesn't really do anything. We'll have a maybe we'll leave that for now, and then we can always add more to it later. I want to just at least get to the point where I can compile something. So I got my food item here with all the food-related things, and my main function, just to see if I can do anything. We're going to comment out basically all of this, I think, for the moment, and we're just going to see if I can make a dish. Now, to make a dish, I need to include dish.cpp. Let's see if this works. G++ main.cpp to dish. Okay, everything seems to be okay for now. But it's not very impressive. I want to be able to do things. So let's start off by being able to add food items to my dish. So this is going to be void add food given a food item. F, and it'll just be foods.pushback_f. Not too fancy. And then we'll do a Now, my food items don't really have anything associated with them besides temperature and salt level, but I think that's okay. So we will do a void print foods, and what we'll do is for I 0, I is less than the size of my foods, I plus plus, and we'll print this food is in degrees and has a salt level of D, where that's the foods I dot get temperature and foods I dot get salt. And then I want to, my main function, be able to make a food object, a food item. So food item fi equals food item 10, 20. Or let's say 1, 2. We'll keep it simple. D dot add food fi, and D dot, what did I call it? Print foods. Let's see if this works. Compile. I missed a brace. Missed a brace. That seems odd. Why would I be missing a brace? Line 32. Well, yeah, this matches that one. That's weird. What else is wrong? Oh, does this one have a missing brace? No, it has an extra one. That's what it is. There we go. Okay, try that again. No, it's still unhappy. Some weird stuff going on here. Those match. Oh, am I short a brace? Oh no, I'm missing parentheses. That's what it is. So parentheses goes here to close that, and then brace goes here to close that. There we go. Some weird formatting issues and really not explaining well to me what the problem was. Okay, now it's just in dish print foods, I'm missing a semicolon right here. Okay, try again. Great, so if I run dish, all right, can add food to my dish. Now, here's the thing though, is this is still kind of messy. I mean, my food item is pretty like whatever, but dish.cpp, basically including CPP files is usually not the ideal way to do it. Sometimes you have to. And in a few languages, this is actually the default way to do it. But in C++, sometimes we actually just want to include the header file, and then we can compile things separately. So what I'm going to do is I am going to use my header file for dish.h. And the difference is just going to be that I'm not going to include how any of this stuff works. I'm just going to declare everything that's in here. So I'm going to cut a whole bunch of stuff. Now, it doesn't look too different because dish.h and dish.cpp aren't too different, but there is one thing I'm going to do differently. Now, instead of including these things, I'm going to include dish.h, which should come with vector and IO stream because it says here, and food item. If it doesn't, I can always put them back. And in my main function, I'm going to include dish.h as well. But when I compile this, I'm going to not only compile main.cpp, I'm also going to compile dish.cpp. Now, you'll notice I get one little error here which says redefinition of class dish. And what that means is that in my main function here, I'm trying to include the dish header. And in my CPP file here, I'm also trying to include the dish header. When you do that, the computer gets angry because it thinks you're trying to run this code multiple times. So you need to tell it not to do that. There's an easy solution, which is if not defined dish, then define it. So now the computer knows that the word dish has been set up. I'll put end if down here. If dish is known to the computer, then it will skip everything in here. If dish is not known to the computer, it will define what it is, so it knows what it is, and now it runs all this code. So this code will only run once, which is what I want. Why is it still saying that? I wonder if it's because of this semicolon here? Nope, it wants a semicolon. But it's still unhappy that I'm including it multiple times. I think it might be that I don't need to include it here. Let me see. Nope, it was very unhappy about that. Okay. Redefining the class. But why am I redefining the class? Shouldn't, because it should only do it once. It's possible I don't need to include it here, maybe? No, that's not quite right. Why is this error coming up? I know what it is. My dish CPP. I don't need to say that there's a dish class. I already know that there's a dish class. All I need to do is define these methods. So let's dismantle this, because all I need to do is say dish add food, dish print foods, and that should be fine. Yeah. Oh, what is it unhappy about? Oh, it needs a type, duh. Add foods is a void, print foods is also void. There we go. Did it say that over here? Yeah, it did. Okay. Void, good stuff. Multiple definition of the food item constructor. So I think the reason for that is because it's first declared in So I think this might be a case where we need to split up this food item as well. So what I will do is I will, do I need to? Sure, let's do it just in case. We will make food item.h. And food item.h will contain all of the contents we had in food item.cpp, except it won't need to have the, I suppose you don't need the exceptions. That doesn't seem necessary. And we will declare the food item class. But we don't need to implement anything. So can get rid of that. Get rid of that, and this, and this, and this. And my food item constructor I'm getting rid of completely because I've already got it over here. And now inside of my food item over here, CPP file, I just need to define these functions. So I can toss all this out. This is my food item constructor. And this is my food item temperature. Get rid of this. Oops. Get rid of this and tab everything back. Set temperature. Get temperature. Set salt. Get salt. And there's my constructor for no parameters. And finally, I will include food item dot h. Okay. How about now? Oh, the last thing is I need to make sure food items don't get declared multiple times. By doing so, I will go if not defined food, define food. And if. It still defines food item a lot of times. Okay, what am I doing wrong here? Oh, I need to compile food item as well, I think. Dish.h, yeah. So food item.h here, and should that be it? Or do I need to include food item.cpp? Ooh, did that work? I think it did. Okay, so I did a lot of stuff there, and so I want to kind of take a look at all the things that I sort of assembled together. I was sort of troubleshooting on the fly here, but I think it's good to sort of see the all of the errors I was running into, and you can always go back and watch everything that I fixed. But it all kind of led to what we have here, which is a little bit more of what we would call modular programming. I've split everything into little modules. The main function here, if I get rid of all the extra stuff, is very short. It's just make a dish, make a food item, put the food item on the dish, print it out. That's it. Now, you'll notice in here I don't actually I don't actually explain where food items come from or even where dishes come from, but I do have an inclusion of a header. And this header we can go to next. This is dish.h, and here is where I declare a dish class. I say what it is, I say what methods it has, but I don't define how any of them work. So this is the declaration. It's not the implementation. It just says, here are some libraries I need. Do this only once. Don't include dish.h 50,000 times. Just one time should be enough so that you can declare these things and be happy with it. Now, I also need to include food items. Food items come from food item.h. Similarly, I don't want to declare a food item multiple times. I just want to clearly say here are all the properties of what a food item looks like. Now, so I got my food item set up here. And now, how does a food item actually work though? You'll notice when I compiled it, I need to actually list every CPP file that's here. And that means that I need to go through all of the code as well, each of which includes the associated header file. So fooditem.cpp includes the header, that is fooditem.h. The CPP includes my exception classes, which you could separate too, but I'm being a little speedy with things. And instead of mentioning the food item class, it just has the definitions of all of the methods that I talked about earlier. Remember, the header already has the explanation of what's in the class, so I don't need that. I can just have the functionality for the food item in here, all the methods and the constructors and so on. In my dish.cpp, again, I just have the functions, the actual code here that does things. This should be tabbed backwards. How to add a food, how to print foods, and I include the dish header. And that's all of the code, but now it's been split up into small files instead of one giant file, because even exercise 4 was getting really big. And now we're kind of reaching a point where we want to be able to work on each module of the code independently from each other. And so, for instance, if I need to modify food items, I don't have to dig around for everything. I can just go to fooditem.cpp and find the methods there, or fooditem.h and find the default declarations there, and make any changes only in the files where that matters. All right. So I think that's everything that exercise 5 was asking for. I suppose we can also like tinker around with this if we don't want to make just a food item that's 1, 2. We can also make a food item fi2, which is using the other constructor, and I can add fi2 and print it out as well, just to make sure everything is still working okay. It should not matter. And our starting temperature 99, solid salt level 40. That's too much. So 99 degrees is okay, a salt level of 5, and everything is working as intended. Great, all right. So exercise 5 was pretty lengthy. Let's see how exercise 6 is. Create a restaurant class and another set of header and CPP files. Restaurants should have an array of available dishes. Include food item, dish, and restaurant in your main function, and instantiate objects of each class. Well, I don't really need to include all of these things, I don't think. I suppose I can. Out of curiosity, what happens if I do that right now? If I go here and I say include food item h and include, well, it's just the 2, right? I don't think this actually matters. Not particularly. So it turns out I don't really need to include this here. So restaurants should have an array of available dishes. You don't really need to include, though. I guess it's okay. All right, so let's do this. Now, I'm going to copy this directory. Or I guess what I'll do is I'll copy all the files here. Copy. Make a folder. That's exercise 6. Here's all of our content. Close everything so we don't accidentally modify the wrong stuff. Here's what we have to do. So we're going to need restaurant.h. Create a restaurant class with an array of available dishes. Okay, so let's make a class called restaurant. It is going to have a private, so it's going to have an array of dishes, which means that probably, so if and def restaurant, define resta, and if resta, and we need to include dish.h. If I don't know what a dish is, I can't have an array of dishes, and I want an array of dishes. So this is going to be a dish pointer, so it's going to point to an array of dishes. And this is going to be available dishes, public, and this is where we'll have a restaurant constructor, and a dish star get available dishes, which, yeah, that seems fine to me. So I'll be able to construct a restaurant. Perhaps I should have a size, actually, of how many dishes there are. And we'll say int size. We'll say int for how many dishes are available, and we'll get a pointer back to that much. Yeah, that seems fine. Maybe I'll get a function to return the size too. Get size. There we go. Okay, this seems fine with me. So here is my .h. Now I also need a CPP file. It's going to have the code for this. And that'll be restaurant.cpp. And here I want to include restaurant.h. I don't need these things. I don't need this thing. I don't need to declare the restaurant stuff, and I'll delete that as soon as I remember everything. But what I do need is a restaurant constructor. And here what we'll do is we will say available dishes equals new dish of size. And I suppose we'll have to take a size for this. And then we'll need a method called getAvailableDishes. Restaurant getAvailableDishes. This will just return the available dishes. And similarly, int restaurant get size will return the size. Make this a little shorter, easier to look at. Okay, that seems fine to me, so I can get rid of this. This makes a really short code. So I got my restaurant. Here's what a restaurant looks like. Here's the code for the restaurant, which is nice and short. And I need to make sure I can make objects of all these kinds in my main function. So in here, I want to make a and also, I guess to make sure I can actually use everything, let's get a void list dishes. And here we'll have void restaurant list dishes for I0, I is less than the size, I plus plus. For j equals 0, j is less than the size of the current dish. The current dish is available dishes I dot size. And so now I'm at the point where I have a food item, and a food item. Didn't we have? Or actually, we can print a dish, right? I think. Did we write that? Yeah, you can print the foods in a dish. So let's actually just print the foods in the dish. We don't need a second list. We can go here, dot print foods. It's more efficient. Print the foods of all of the available dishes. Now my main function, I need to include restaurant.h. You can include the others, but it's not necessary. And I will make a restaurant r. There's a dish. And we'll add 2 of those dishes. So, I guess I need to use the constructor for this. Is restaurant 2 dishes. Do I have a way to add dishes to my? Well, I can get the available dishes. So dish pointer is r dot get available dishes. R0 equals d. R1 equals d. And r dot, what was the method called? List dishes. Let's see if this works. If it doesn't work, I'll have to fix it. But if it does work, then I can go and talk it through. So I need to do, basically, can I do everything dot cpp into restaurant? Does that work? Okay, what is it unhappy about? Cannot convert get available dishes because it's supposed to have a parentheses. So I'll fix that. Oh, right. So I'm trying to access the dish from the restaurant, but I'm supposed to be using it from the pointer. Pointer. 80 and 200. Okay, and it says it 3 times because I said to print it an extra time, which is not necessary. But let's clear that, rerun it, and then we'll walk through what just happened. Too big and salt of 5. Did that not work? Okay, let's try setting the temperature to be something normal and the salt level to be low. No, it's not printing anything. R.list dishes. Oh, 1 sec. So, I think maybe it has to do with something that's going on here. So right now, I am making my restaurant. I make my dish. I make my 2 food items. I add them to my dish. And now I make a array of dishes, and I want to put the two dishes into that array and then list them. But it doesn't seem to be working. Let's double check that. So compile, run, nothing happens. Okay. What if I go and, so here's my restaurant. And list dishes is supposed to go up to the size. Oh, I forgot to set the size. No wonder. No wonder. Very silly error. Available dishes, and the size is S. That will help. Okay. Go and go. 101, too hot. Salt level 6. There we go. So I got 2 copies of, is that what's going on here? I seem to be calling it twice. This food is 1 degree and has a salt. Oh, right. Because so I added food twice. Why is it printing it out so many times? Oh, right, because each dish has 2 food items. Okay, so this is dish 1. Let's since I'm confusing myself with my own code, I should write in text to help myself. So what we'll do is we'll print dish number I. And then we'll print a new line below. And this should make it a little more legible before I go back and explain every weird thing I just did. 800, too hot. Salt level 4. Okay, here we go. Dish 0, dish 1, because I forgot to add one of them, but that is okay. Let's review everything that we built here. Our main function now builds a restaurant, a dish, food items that go on the dishes. I used to print them, but I don't need to. Here is kind of weird, but right now my restaurant doesn't have a function to add dishes to it. Not really ideal. I probably should fix that if I was doing this properly, but kind of just want to get through it at the moment. So instead, I get a pointer that points to the array of available dishes contained within the restaurant class. So here's the restaurant class with no code. It's just the declaration of what a restaurant is. It's an array of dishes, how many dishes those are, the constructor. I can get that array, I can get the size, and I can list the dishes that are there. Here is the code to do so. And when I get the available dishes, it returns a pointer. This is just a pointer to this array, because it says make an array. Probably might want to make a vector instead, but array will be fine. In my main function here, I get that pointer, and I use that pointer, and I treat it just like an array. And so I can use pointer 0 and pointer 1, and store in them 2 copies of my 1 dish that I made. And I list them out, and that's what I see. All right. All right, we're going to continue and delve into exercise 7. Create a utility file that contains various functions such as cook, salt, and serve. They should take 1 or more food items as parameters. Include this in the main function and call them. All right, let's go. So just like before, I'm going to grab everything from exercise 6, copy it into a new folder, which is exercise 7. Paste them all here. We're going to need a new file called util. I suppose .cpp is fine. You could also make this a header file potentially if you wanted, but we'll make it a CPP file. Because I think we're only going to call it. We're only going to include it once from our main function. Now it says it needs some functions, such as cook, salt, and serve. So let's see what those do. We're also going to need to include fooditem.h so that we know what a food item is. Now, my cook function is going to be a void. It's going to take a food item. And I think what we'll do to keep it simple is just print that it's going to cook it. Cooking. And we will set the temperature of the food item to be a little higher than it was. Plus 10, for instance. And my salt function will be salting, and it will set the salt to be also a little higher. And our serve function will print serving a food item with and I think here, maybe we'll just be a little lazy here and we'll just say we're serving a food item. Perhaps if our food item had a way to print it out, we would use that, but here we'll just keep it simple. Okay, so here are my utility functions. I've kept them in a separate file, and my main function is just going to include it. Just include util.cpp. Now what you'll notice here is that I'm including header files and CPP files. If I include a CPP file, I don't need to compile it along with all my other ones. If I include a .h file, then that's not going to be listed among my things that I compile, but I will need to compile the associated restaurant.cpp. So over here, when I compile, I need to do G++, and we'll make this utility main.cpp, food item.cpp, and dish and restaurant. Also, I probably should call these functions I just made. So here we're listing the dishes. Perhaps we'll cook the food item fi. Why not? So we'll cook fi. We'll salt fi, and we'll serve fi before we do all of our other stuff. And let's see what happens. Utility, go. Cooking, salting, serving a food item. We have another one that is going to be 40 and 1. And our other one is 1 degree with a salt level of 2. Is that quite right? Let me see here. I can already tell I made a mistake, which is these are pass by value functions. They're not pass by reference, so I'm not modifying them. I want to do so, so I will need to pass them all by reference. Try it again. Starting at 40 and 1. And now we can see that my 1 degree food got cooked up to 11 degrees and went from 2 salt to 3 salt. So I'm actually using my utility functions. Always important to remember those pass by reference symbols, otherwise this code doesn't really do anything. But that's pretty much all that I did. And that was pretty quick, which beats spending too much time on these exercises. Let's see if we can wrap up the third one. Okay, last but not least. Create several classes and functions, each in their own files representing different components of a kitchen. Oven, cutting board, mixer, etc. Include necessary files in your main function and compile them when executable. So I feel like this is one that is better to leave open. I'm probably going to do one. Maybe we'll do cutting board. But I think that you should try making all of these different parts and including them for yourself to see what it looks like. Now, as before, we'll grab everything, copy, make a new folder, exercise 8, drop everything in, close all of our work. Now we've got so we are going to make a cutting board. Why not? So cutting board.h. This is going to be a class called cutting board. And it will have a private variable, which is a food item. This is a header, so it needs, if not defined, cut, define cut. And we'll need to include food item.h so that we can make a food item on our cutting board. And we'll call this to cut. And our method is just going to be cut. we'll keep this kind of basic. You can always expand this out as you feel like it. Okay. I suppose I should have a constructor as well, which takes a food item. Okay, and then we'll make a CPP file. And now here, we don't need to declare these things because that's been done, but I do need to make my cutting board function, which constructor, I should say. And this is just going to assign the thing to cut to be that food item. And my cut function, again, will be a little simplistic and say, cutting the food. Okay, so I'm cutting the food. Great. I will go and also include cutting board.h because that's where the cutting board itself is declared. And now in my main function, I just need to include cutting board.h. And we'll make a cutting board. Board C equals cutting board, and we'll put FI on it. And we'll do C.cut. And to compile this, G++-O cutting, and we'll compile main and food item and restaurant and cutting board and dish. Oop, I missed something here. Cutting board does not name a type. Did I spell it wrong? I don't think so. What did I mess up? Did I forget my utils? No, util is already included. What did I mess up here? Could be that my code is not recognizing that the cutting board exists. No, that didn't help. Can I just declare it there? Is that sufficient? Am I spelling this wrong? Oh, there's a capital B. That's what it is. I think. Wait, is that the problem? Oh, this should be a capital B. Invalid use of incomplete. Oh, I'm having a heck of a time here. What is the issue? This is my cutting board. Oh, I wonder if it has to do with my inclusions here. I think I'm not going to include this and see what happens. Nope, that didn't work. Oh, these shouldn't be here. I think that might have been it. Okay, we're almost there. Void, that was, so I wasn't supposed to put those in because that's part of a H file, not a .cpp file. And then finally, this is part of the cutting board class, so that should be there as well. There we go. 2, 3. Cutting the food exactly as I wanted. So the mistake I made is I had left in this part here, which meant that since cut had been set by my header file for cutting board, it never properly ran everything for the we actually never got into this header file. We immediately went to cutting board. It defined cut, so the computer said, oh, I know what cut is. I'm going to skip this header file and not read it, and then didn't know what a cutting board was, which is a problem. So make sure that you only have your if and defs in your header files, not in your CPP files. Okay, I think that's everything for this set of exercises. It was a very long video for sure, but I think it's very important to understand, first of all, what kinds of issues you can run into when you have lots of files here. Look at this, there's so many files. But also the ways that these header files and CPP files interact with each other, and look how many I have to compile just to get this to work. And so you can see that this is getting very tedious, and shortly we're going to talk about ways that we can simplify the process of compiling a whole bunch of CPP files at once, and I will see you when we talk about that later.